So first thing is I give you the cotangent ratio. And on that triangle there, cotangent of x, you got to know what that triangle looks like. So when I make my triangle there, I first am always going back to a cotangent ratio. What's the tangent ratio? So that's what I did right there. Given the cotangent ratio, what do we know then? We know the tangent ratio immediately. Cotangent is the reciprocal of tangent. So I take that, I know the tangent ratio is 3/4, and I wrote that in wrong. 3/4. I gotta fix that. Okay, I know immediately it's the reciprocal of 4/3. It's 3/4. I technically don't know. Okay, I take that tangent ratio, I make my triangle. Standing at the x, then I don't care where you put the x. You do the top angle, bottom angle, we talked about that. Now just be consistent about your opposite and adjacent. Tangent is opposite and adjacent. That's where I'm running with. We've been using that. Standing there, here's my opposite, which is 3. Here's my adjacent, which is 4. I want you to find those other ratios. In order to find those, we got to know, obviously, the hypotenuse. It's a 3, 4, and, yep, it's a 3, 4, and 5. So with that 3, 4, and 5, alrighty, okay, with that 3, 4, and 5 now, just stand the x, and we go back to what we did last week. I think it was Wednesday last week that we started writing the ratios of sine, cosine, and tangent. So standing at that x, okay, standing at the x, I don't know what the heck I did there. All right, for x and 4/5, I must have just not done my ratios completely correct. I wrote this right, but then jacked up the other parts. Standing at x, okay, I should have had actually what? 3/5 here, and cosine should have been 4/5. Okay, I got those two things mixed up in my head when I made the key. That is my bad. All right. What's that? Yeah, I'm gonna go fix those too. So I'm gonna bring up that file so I can fix those at the same time. So then after that, I gotta go then do. I want to go do my reciprocal functions, and all my reciprocal functions. Okay. Okay. On that cotangent. Well, we already knew what the cotangent ratio was. We got that one. 4/3. Okay. Cotangent was given to us. But then the cosecant ratio. Cosecant is the reciprocal of sine. So where sine was 3/5, so therefore cosecant is 5/3. It's the reciprocal of sine. Okay, so I'm going to fix that. Thank you for pointing that out, Brianna. I need to go fix those. So I guess when I was doing that in my head, I just totally jacked up the opposite and adjacent. Okay. So again, when I see that problem, make a triangle. I go is back to the reciprocal of 4/3 for cotangent, which is 3/4 tangent, and then put the x wherever you want. I don't care. Most of us probably are going to go at that bottom angle. Cool. And then throw out the opposite adjacent, opposite hypotenuse, whatever you got. Make the triangle. Okay. Good question there. Forgot to record that. Is the again what would you call is the secant ratio? In this instance, it's the adjacent over the hypotenuse. Let's shoot. Hypotenuse, sorry, hypotenuse over the adjacent. So in this instance, what's it going to be? AB over AC. Now, I never, again, remember as hypotenuse over adjacent, as I keep talking about. I always keep remembering as reciprocal of cosine. Over time, I don't have a great mnemonic device there. I just have to remember it as e goes to cosine. It's a little confusing. I did that. Now this one is usually pretty obvious. It's got the t's. Cotangent, tangent's got the t's. These two, they are very similar, right? remember is S goes with C. C goes with S. Sine goes with N cosine. S goes with C, C goes with S. That's how I always, on my teachers way back when, suggested, okay, S goes with C, C goes with S. Alright? So sine goes with cosecant, cosecant, cosine goes with secant. Alright, so they kind of run opposites of the Alright? So you just gotta put that in your head. So it's the reciprocal of cosine. Alright, just like we've been doing, let's do a practice with it. We've already laid the groundwork for it on cotangent. We did it yesterday with what? Cosecant. And then today, let's do a little practice with secant, and then we're going to turn our attention to that little that paper we did yesterday, and let's do some more practice on it. Okay. So let's do that. Okay. Where's my triangles at? They don't put the triangles to the next page. Yep, right here. So on this one, let's do a secant ratio. I want to do the secant of angle A. Okay, just like we've been doing. Again, this should not be like a crazy problem now. We've already done the cotangent. We've done this cosecant. It's the same idea. Now again, I always start off by going to its original. The trig function that goes with is what? Cosine, right? So before I do the secant ratio, I'm going to go do the cosine of A. That's just me. I'm staying at A. Cosine of A, adjacent and hypotenuse, right? So I'm going to write that out. And then I flip it. Then I do its reciprocal, and then I deal with that. Then. If you don't want to do it, cool, I don't care. But now I'm going to deal with that. Go deal with it. That's my first step. That will get you half credit. Because what do I have to now deal with? I rationalize. I can reduce 8 over 4, right? I got two things I got to deal with. Go deal with it. This is nothing new now. The new part was right here. Realizing it's the reciprocal cosine. That's the new part. We're done. This rest of it's old stuff. Really, the old part's algebra. 8/4 becomes 2 over root 3, right? And then we rationalize. I like to reduce with smaller, work with small numbers. We know that. And you guys have all done this before. Root 3, 2 root 3 over what? Yep. Perfect square of 9, which is just 3. Boom. That's it. Okay? And we've done all that hard work. Alright, let's go do one more here. Let's go stand at angle B. Same problem. Let's go stand at B though. I'm going to use that little space below that. Secant of B. Secant of B. So we're going to change our perspective, aren't we? What is now my adjacent? 4? I think that's what I heard. My hearing is already going because I'm old apparently. Plus the fan. So thank you. Alright, so my adjacent is now 4. And it's 4 over 8. Right? Right? I don't think so, is it? Because remember, it's the reciprocal of what? I always go to cosine first. Cosine is the 4 over 8, isn't it? And then I do its reciprocal, which is, right. Those are the small mistakes I see. So just watch yourself. Okay, it's easy to do. And 8/4 is just 2. Yep. Small mistakes I see. Don't get too cocky there. Alrighty. Let's go with one more here. Next door in that 45. Pick one, guys. E or D? Sorry? Does it matter? Nope. It's 45, right? It's going to be the same either one. So it did matter. You guys had the illusion of choice, which you really didn't. All right, this is a secant of E. This is a dictatorship in here. It's a benevolent dictatorship, but it's a dictatorship nonetheless. All right, secant of E. Caden had a choice here, right? All right, Caden. We're gonna go with the cosine of E. Jason over hypotenuse. 8 over, right? The reciprocal. Do I have to rationalize on this one? Well, it looks like it starts off like that. Don't worry about rationalizing until you get to that next fraction, until you reciprocal. And all we have to do is what? Reduce those 8s, don't we? Root 2. Nope. And just like we did, let's do one more here with evaluating. We've done a cotangent, we've done a cosecant, let's do a secant. Evaluate something. You got some blank space, let's use it. Evaluate the nope, sorry, we're on the secant today, aren't we? My bad. Somebody give me a number. 12? Very nice number. I don't know, it might be a bad number, I don't know. Works for me though, Brianna. Is that your favorite number? What's your number? 24? Should go with 24. I don't care what it is. As long as it's not more than 90, I'm good with it. What is it? What do you want to go with? I don't care either. Okay, let's go nearest 100. Farther? 10 thousandths. Alright.
10 thousandths?
Yes, 10 thousandths.
It's a lot of work.
What's that? Oh, that's easy. 51.
51?
Yep.
You're that kind of person? I mean, that makes sense.
It's not.
It's a weird number.
You're a weird person.
So are you.
I know. But as soon as you accept it, you're good with it. 51. It's my favorite baseball player. I think we've had this conversation.
Oh, yeah, we have.
It's my favorite baseball
I
player.
forgot.
Also followed by 11.
11.
All right. 42's up there as well. 42's the answer to everything, by the way.
No, it's 23.
If anybody ever's read the book.
What?
James might have. James is a dork like me.
He
Have
is.
you read that book series, James?
What book series?
42. The answer to everything.
No.
It's a good book series.
He only reads his book.
If you like quirky humor,
No one would like
shut
it.
up. Like quirky humor,
What is
sci-fi-ish, Hitchhiker's Guide to the Galaxy.
1, 2,
Okay.
wait.
All right, James, I think you'd be up your alley.
Thousands.
All right. We're at Birds of a Feather. I think you'll like it. Okay, Hitchhiker's Guide to the Galaxy. All right. Secant of 12. Can't do it in our calculator. So 1 over what? Cosine, right? And our calculator can do that one. We've seen that now the last couple of days. We got to do 1 over something. In this case, 1 over cosine. And Yante forced us to do nearest 10,000. And what is the nearest 10,000?
What?
What is that? How many decimals?
4.
That is 4. Right. Okay. Yante's really pushing us today. So 1.1, 2, 3, and 4. So we stop at the 3, look at the 4, and it says to what? Keep it. Yep. So 1.0223. You guys will miss me. You only got stuck with me for less than 43 more school days. But you'll miss me. Probably not.
Probably will.
What's that? Next year, what now?
Do you teach any other subject?
I'm out for one jump. I like drawing. Sorry, I say I like freshmen. I tolerate freshmen.
Or your favorites.
I
Let's be
tolerate
real.
Sydney.
Wait, so who algebra tutored you?
I'll know schedules maybe better tomorrow. They're meeting. But usually right now it's we had this man to this river. That's all I know.
I'm finna ask her about this.
That's all I know. But usually I'm stuck right here at Albert One Geometry, which really I like. I do like.
Yeah.
That's been my schedule like 18 years.
Hopefully, I don't really see that.
Hopefully what?
Hopefully it changes.
Hopefully it changes.
When I came in, everybody's like, "You really want to crush?" Because he's like,
It's ain't like
I don't know about
and
that.
I'm like, "Okay."
Well,
let's
you
see
got
if
the
I
wrong
get it."
dress, right? I know.
Not that one. I don't even know that one. I didn't even know that existed.
She is the better dress. You got stuff with me. Sorry. All right,
What does
let's
she
get
do?
out the
She
other
teaches
paper,
math
guys.
specifically.
Yes, she's a great stats teacher. She's a great overall dress teacher. Sorry. All right, get out the other piece of paper, guys.
Oh,
Yep. Let's do some applications here.
no.
Yes.
I don't want to do
Well, I don't really care. We're home.
Hey, we're not trying this.
It's not.
It's not.
No, I
Y'all can get me off the test. I don't care. We're coming right back.
Oh my gosh, my 8th grade year, our social studies teacher, we get off track for the whole hour. Like, nothing social studies related. It was always like, it was like a debate that happened. Didn't we do it?
Okay, number 3. Let's do this. Yesterday, y'all made fun of my
Yes, I did.
our artistic skills, and so did my second
Hey, we
hour,
don't have room to talk.
and so did my third hour. I went home and cried. Thank
Wait,
you.
is there a pattern?
Yes, there is. I went home into the fetal position and cried. Thank you.
They weren't that much years.
Aw.
Okay, let's get going here.
Why can I imagine?
Sketch out that picture, okay? Sketch out that picture.
At least it looks like it could kind of. I don't know.
Somewhere in that page I just gave you, Spencer. That page just gave you, okay? All right. Now, as we talked yesterday, and we had a little fun grooming direction, okay? As you, well, everything boils down to what type of triangle? Right triangle, yes. So, on this, as you sketch this out, okay, it does not have to be as beautiful as my triangles are. Sydney? No, sorry. Yeah, no, sorry about that. Stuff your sorries instead. Okay? So, with this, okay, you got yourself a rock climber here. All right? It boils down to some type of right triangle. Okay? And with that right triangle, we then talk about angle and elevation and pressure. Depends on where that angle goes. That's it. Okay. So, as you're sketching that out, it boils down to right triangle. All right, you got yourself a rock climber on a cliff. You cite, I should say, a rock climber on a cliff. Now we do have a new piece of information here today. We're going to have to talk about that. It's going to change things around ever so slightly. And you're 1,000 feet away from the base of the cliff. So there's my cliff. We're going to go for a little bit of plateau there. All right, from that. No,
It looks like a fire pole.
it's clearly rock climbing.
Clearly, with all the ridges and the rocks.
They like 100 feet tall.
It's not to scale. Shush.
Well, we can tell.
No, okay, so,
Yes.
okay, so there is the most beautiful, accurate to scale drawing ever.
Oh, for sure. We all said it wasn't to scale.
Shut up. There you go. That's what's happening, right? Now, as we take a look here, though, compared to the other one that we did yesterday, I didn't make this to the ground, did I?
No.
Because this time we have an eye level. So when I do make this triangle, though, I do not have it again at ground level, do I? Because as I start throwing some information now, we do have that information about being a little bit above ground level, don't we? How much above ground level? 6 feet. Essentially your height, right? Now, off of there, get some other information thrown there. You are 1,000 feet away from the base of the cliff, right? So where's that going to go? That's your bottom, right? The bottom leg, right? The horizontal leg. All right. The angle. Plus it. Plus it. Everybody has imaginary horizontal line. Okay? You may not see it because it's imaginary. Imaginary friend might see it. Okay. So coming out of you, everybody has imaginary horizontal. Remember, depending on where you're looking, it's all relative. So we're looking up. It's always off the horizontal. That line that's formed is above that horizontal. That's the angle of elevation. You look down. That imaginary horizontal line is still there. As I look down here, okay, that is an angle of. So that angle that is formed right here on that imaginary horizontal, where I'm looking, that's an angle of depression. So in this instance, when you throw that 32 degrees in here, where is it going? The bottom angle or the top angle? It's going at the bottom. Because you are the one that sights the rock climber. You sight that rock climber at a 32 angle of elevation. So that's the angle that's being created by the horizontal. So that's that 32 degrees looking up there. What are we actually trying to find? The approximate height of the rock climber, right? We've got some trig together, right? We got a right triangle. We got some trig going on. What type of trig do we have going on? Sine, cosine, or tangent? Tangent, right? Saying at 32, which we know, we have the opposite. We have the adjacent, right? So let's go off to the side. Tangent of 32 equals opposite over adjacent, right? Nothing really crazy. The biggest part is, can you interpret the scenario? Can you interpret Mr. Christian's drawing? Okay, shut up. All right, 1,000 times the tangent of 32. Let's go to that calculator of ours. It's ready to go. I forgot to make sure I'm in the right mode. I am. 1,000 tangent of 32. And I don't think it did officially tell us how to round.
No.
No, let's just go to nearest whole number. So in this instance, 625. 625 feet. So we can say the rock climber is roughly 625 feet above the ground. And you circle that answer. Is it going to be right or wrong? Why is it wrong? We add the 6 feet because we're not at ground level yet. Because of knowing that height, you give me that answer, you're close, but we're not at ground level. The way that we have this information this time, we do have that additional information of knowing your height. Sometimes it's included, sometimes it's not. Yesterday, if we look above on our windmill one, the windmill did not give us the height information, so we went straight to the ground and called it a day. I think it was like 80 feet, I think it was. And we just were done and called it a day. But if you have that height information, go ahead and include, add on that 6 feet, 4 feet, whatever they say is the eye level, your height, you include that. Okay? So, as Jillian pointed out, plus 6 feet. So this is 625 plus that 6 feet, which is what? There's that 631. Okay? Now, off of here, let's finish this last one with number 4, which is kind of a similar scenario, but this last one here has a angle of depression, which tends to be the one the students mess up the most. All right. Now, as we finish this last one here, again, it all boils down to a right triangle, correct? Now, I'm gonna forego my, my Monets, my Picassos right here. I'm just gonna go to a right triangle. Okay, so I know I'm gonna leave those all to you guys. Okay, you're quite welcome. What's that? Yeah, I'm gonna forgo all those. My Rembrandt. All right, I'll leave those to you guys. My Degas, just be all you guys. I'll leave those to the professionals. Okay, it's an angle of depression, right? So we got Boy Scout on top of a very tall, lonely mountain, misty mountain, right? Right, James?
What?
Very
Yeah.
tall, lonely, misty mountain.
Yeah.
Here's a reference.
Yeah.
You should. Which is for you guys. Yeah, all right, okay, I hope so. Unless there's any other birds and birds out there.
No.
Any hobbits out there? Birds? Okay.
It's like a book.
It's like a book. Is it like a book or something?
Or is it a movie?
Our movie. Okay, what came first? Book or movie, right?
Probably.
All right.
I mean, yes.
All right. So here we go. Angle of depression. All right. With that angle of depression, then everybody's got this imaginary horizontal line. Now, in this instance, angle of depression, where were you looking at? Above or below? So at the top of that mountain there, we spot that campsite below that angle of depression. So I always draw that dash out that top of that mountain there. As we look down, where's that 30? What was it? 35 going. I got two angles up there. Angle 1 and angle 2. So where's that 35 going then? Angle 1. Angles of elevation depression are always built off of what? A horizontal. So it's going right underneath the horizontal. How far is the campsite from the foot of the mountain? There's my X. Okay. We got a right triangle. We got some labels. I like to bring my depression in as an elevation. From the campsite's perspective, looking up, it's an elevation. From the mountain's top down to the campsite's perspective, it's a depression. Those angles are congruent. We're good to go. We got a triangle again. We got another tangent, don't we? You will find on a lot of these word problems, tangent pops up quite a bit. Not always, but quite a bit. Finish it off. 1700 divided by the tangent of 35, don't we? And we're going to go to nearest whole number again, because who cares at that point? Somebody give that what? 2,428? 2,428. What did I just say? 2,428?
Yep.
Okay. All right. So